Now what we have given here is find the beam area. We have to find the beam area here. Beam area, beam area of E here. This is capital E of theta here. Capital E of theta is equal to cos square theta here. And this theta is going to vary between 0 to 90 degree. What we have to do here is we have to calculate the beam area. The electric field equation has been given here, or you can say energy equation has been given here. Okay, and the corresponding limits has been stated here. We have to calculate the exact method and approximate method here. Beam area, okay, to be calculated with the help of exact method and approximate method here. Now let us solve this particular first one here. That is, we know that power is equal to E square here. That is energy square, or you can say electric field square here. So now E of theta is equal to cos square theta. You know the limits here. Okay. Now we have a beam area, okay, equation here, which is nothing but here it is going to vary the azimuth angle as 0 to 2 pi here. Okay, theta is equal to 0 to pi here, and there is a power, normalized power equation was there here in this place here. Normalized power equation and solid angle here. You know the normalized power equation is given as cos square theta here. Cos square theta is nothing but here E square you can consider. P is equal to E square we have to consider here. Okay, so normalized power pattern has been given here, that is cos square theta here. That should be squared here. Okay, you know the solid angle. Solid angle is nothing but a sin theta, d theta, d phi, and the limits are already given. Theta is equal to 0 to pi here. Substituting all the values in the beam area here. Okay, 0 to 2 pi, 0 to pi by 2, cos square. Okay, cos square theta whole to the bracket square again here. Okay, so what we will be having here? So you know the integration of 0 to 2 pi d phi here, that is 2 pi. Theta 0 to pi by 2 you have to do here. Cos raised to 4 theta sin theta d theta. You know how to evaluate this particular thing here. Cos theta is equal to t here, minus sin theta d theta is equal to dt here. If at all we put theta is equal to 0, okay, t is equal to 1 will come here. Theta is equal to pi by 2 if you put here, t is equal to 0 will come here. So that's why 2 pi into 1 to 0 minus t raised to 4 d theta. If at all we wanted to change the sign of this this particular value here, just need to interchange the integration terms here. That is limits we have to interchange here. So instead of 1 to 0, let us put 0 to 1 here. Then we'll have this t raised to 4 dt here. The minus will be replaced with the plus here. Okay, if at all we find the integration of this one, t raised to 5 divided by 5 will come into picture. Substituting the value of 0 to 1, we will have the value of beam area as 2 pi divided by 5 here. That is nothing but here. This can also be written as 1.256 steradian here. Okay, okay. Now 1 steradian is nothing but here 32883 here, but this is not necessary right now here. So now just remember here beam area 2 pi divided by 5 here. Now how do you find beam area with the help of this approximate method here? Now whatever we have solved is nothing but here this exact method here. In this exact method, what you have to do here, you have to get the power equation here. Anyway, electric field equation, or you can say energy equation has been given here. Okay, how much energy is there? So what you have to do here is just take out the power equation, and I mean beam area in terms of power, and substitute the value of electric field or energy here, and you get the value of beam area. That is exact method here. Now, how do you find the approximate method here? The approximate method is given as beam area is equal to theta hp into phi hp here. Remember, a little bit of blurriness is there here. Theta hp into pi hp here. Hp is nothing but half power here. Okay. So energy, that is E theta at half power, is given by 1 divided by root 2 here. That is nothing but 0.707 here. So cos square theta is equal to whatever the E theta we are having is cos square theta here. Cos square theta is equal to what here? Cos square theta is equal to what here? 1 divided by root 2 here. That is nothing but here 0.707 here. Okay, so just calculating the theta value, we will have 33 degree here. As we don't have any kind of a phi terms in our electric field equation or energy equation here, that's why even whatever the theta value is, it is equivalent to phi here. Okay, theta hp is equal to how much here? Half power. half power beamwidth here, 2 into theta here. Okay, that is nothing but 2 into 33 is equal to 66 degree will come into picture here. I will let you know how exactly this 2 theta we are going to consider here. Okay, so so what is it now? So half power beamwidth is nothing but 2 into theta here. It is nothing but 66 here. You know the beam area equation. Beam area's equation is equal to theta hp into phi hp. That is 66 degree into 66 degree. We will be having 4356 here. Okay. Now one steradian is equal to 3283 steradian. So beam area is equal to 4356 divided by 3283 here. So we'll be having 1.32 steradian here. Okay. Remember here. So now beam area which we have calculated here with the help of exact method and approximate method are almost similar here. It is having a 1.256 here. It is having 1.32 steradian here. Okay. So this is how we are going to find the beam area, that too with the exact method and the approximate method here. Okay, in the exact method you need to use the power equation. Okay, the approximate method, okay, we need to find the half power here. Remember, half power. Okay, and the equation is also there regarding the beam area here, finding the directivity here. Let us move on to the next question here, that is find the exact and approximate directivity here. He is asked only the beam area in the previous problem here. Now we need to find out the directivity using the exact and approximate method here. Okay, now it's been given as a directional source here. Again, the intensity has been given here, theta value is given here, and phi limits are given here. Okay, it is very easy to calculate here. You know the equation, power equation here. Substituting the value of theta and phi, and whatever the intensity we are having here, right? Intensity is nothing but um sin theta, sin q phi, and sin theta here. D theta, d phi. Again, it is very easy here. 0 to pi sin cube. You know the value of this one here, and you also know the value of this one here. 0 to pi sin square theta here. Now, a sin cube could be replaced with 3 sin theta or 3 sin phi. You can write in this particular here minus sin 3 theta divided by 4. This could be replaced 1 minus cos 2 theta divided by 2 here. You know the value here. If at all we integrate 0 to pi sin cube theta, we'll have the 16 by what you can say that 16 by 3 value will be having. If at all you are going to integrate this sin square theta 0 to pi here, sin square theta 0 to pi d theta here, will be having the pi as the answer here. So ultimately we can write as um, okay, into pi divided by 8 into 60 divided by 3 here. How this 8 comes into picture is nothing but 4 into 2. The 8 will come into picture here. Um divided by 8 into whatever the pi is there into 16 divided by 3 here. So you get the power equation here. Now we have to find the directivity. Again, we need to utilize the isotropic point source power here. Okay, so D is equal to 6 will come to picture here. Now, approximate method in case of directivity here, how do we find here? If at all we have a sine function here, what we have to do here? Theta is equal to 2 into NTM minus of theta here. If at all we have a sine function here, okay. If at all we have the cos terms here, or you can say cos functions here, then we need to have theta is equal to 2 theta here. That's what we have done in the previous problem here. That is, we are having the cos term here. So that's why theta is equal to what you can write here, 2 theta here. Okay. So again, approximate method here. How do we have the sine term here? In this particular equation, what are the terms we are having here? Sine and sine cube is there here. Sine and sine cube, not sine square. We need not to consider this what you call solid angle here. Just consider whatever the intensity we are having here. What are the theta and phi terms? The intensity equation itself only. Okay, so what is the sine theta we are having and sine cube phi we are having here, right? So what is theta value here? Sine theta is equal to 1 by 2 here. In this case, remember half power 1 by 2 we need to consider here. In the previous case, we have to consider 1 by root 2 here. Here is 1 by 2 here. Now theta is equal to how much now? We can sine inverse of 1 by 2. This theta is equal to 30 here. You know it is a sine function here. That's why theta is equal to 20 minus of theta. So theta naught is nothing but here you get 120 here. Now the second term here. Now the second term is sine cube phi here is equal to 1 by 2 here, right? Okay, 1 by 2. So theta is equal to how much of sine inverse of, okay, cube root of 1 by 2 here. So we'll have phi is equal to 52.53 here. Substituting in this phi naught here, we'll have 75.8 naught. Now, not 8, 75.08 here. Now, if at all we wanted to find the directivity here, d is equal to how much is there? This is the standard equation. Remember here, 41253 divided by theta naught and phi naught here. So we have found out the theta naught and phi naught value here. Theta naught is 120 and phi naught is 75.08 here. Substituting the value, you will get d is equal to 4.57 here. This is how we are going to find the directivity in case of approximate method and exact method. Exact method is very easy here. We have to follow, intensity will be given here, get the power equation, get the power equation conserve with isotopic point source, and d is equal to uf divided by u naught. That is exact method. Now, how do you find the directivity in case of approximate method? Is we need to find the theta naught and phi naught here. Okay. So in this case, because here remember sine term is equal to 1 by 2, because just because the intensity terms has been given here, that's why 1 by 2. In the previous case, what we are given as the previous case, we have taken 1 by root 2. No, it is just because of that it is having the electric field equation here. Remember, half power is 1 by 2, electric field intensity 1 by 2. Remember that also here. Whenever the electric field E theta or E energy is given here, so we have to take half power as 1 by root 2 here. Whenever the intensity pattern is given here, you have to take 1 by 2. Okay, remember this particular point here. Okay. So now let us move on to the next problem here, 4.6 here. Okay, a linear array of 4 isotropic point source. Okay, linear array of 4 isotropic point sources. The distance between the adjacent element is lambda by 2. The power of light of is the power of light is equal magnitude, and the phase difference is minus dr. It is minus dr here. Obtain the field pattern or power factor here, and obtain half power beamwidth here. Now, what is exactly the given things are there here? He has given the n here. N is nothing but here 4 isotropic point source here. He has mentioned here, right? 4 isotropic point source he has mentioned here. 4 means n is equal to 4 number of sources here. Okay. Now he has given the distance between the adjacent element here. Distance between the adjacent element is nothing but here d, small d is equal to lambda by 2 here. That is this particular term. And he has given as that whatever the phase difference is there, delta is nothing but here phase difference is minus dr he has given. That's why we are hitting. Given terms is delta is equal to minus dr, d is equal to lambda by 2, and n is equal to 4 here. Okay, this is what has been given here. Now, how do we find the field pattern here? Okay, field pattern he has asked us to find out the field pattern here. Okay, now now to find the field pattern here and half power beamwidth here. So what we have to do here is, so you know this particular equation here. Total phase difference is nothing but here phi is equal to how much here? Phi is equal to dr cos, sorry, psi is equal to dr cos phi plus delta here. Okay, psi is equal to dr cos phi plus delta. That is nothing but here total phase difference here. So total phase difference, let us consider as 0 here, or we don't have any total phase difference here. So at this moment here, dr cos phi minus dr here. Dr is nothing but here already given here. Okay, so if at all we take the dr as a common here, cos phi minus 1 will come into picture here, and cos phi is equal to 1, and cos inverse of 1 is 180 degree here. This is how you are able to find the major beam here. Okay, major beam, okay, or main beam here. So delta is nothing but here phase difference between the adjacent sources here, and phi is nothing but here angle between the positive axis here, x-axis here. So dr is the distance in radius here. Remember, radians here. Okay, so dr is equal to 2 pi divided by lambda into 3 here. Okay, this is how we get the major lobe here. Now let us find out the minor lobe here. Minor lobe, you know the equation here, electric field equation of linear n array here. That is E of sine n psi by 2 divided by psi by 2 here. Sine psi by 2 here. Okay. So if at all we wanted to get the pattern maxima here, what you have to do here, sine of something should be equal to 1 here. That is nothing but here sine of 90. Sine 90 is equal to 1 here. That's why n psi by 2 is equal to plus or minus pi by 2 into bracket of 2k plus 1 here. Now you know how to do all this further things here. That is nothing but here you know the value of psi here. Psi, what is the value of psi here? Psi is nothing but dr cos phi plus delta. You know the dr cos phi delta value, you know minus dr here. Okay. So again cos phi minus 1 dr, you can take it as a common here. Okay. Now cos phi is how much here? You can write this one here. You can take this whole dr n to the RHS side here. Okay. Then this minus 1 can also be taken to the RHS side here. Okay. So now what is remaining? Phi is equal to cos inverse of plus or minus 2k plus 1. Okay. Divided by 4 pi plus 1 here. Okay. So k is equal to 0, 1. Now substituting the value of k is equal to 0, 1, 2, we will have this phi value 41 degree, 75 degree, and okay, which is what 104. Okay. Now this is how the pattern maxima you will get here. What about pattern minima here? Sine of something, or you can say the sine of n psi by 2 should be equal to 0 here. If at all we wanted to find the pattern minima here. So again nothing but n psi by 2 is equal to plus or minus of k pi here. Okay, you know the value of psi, dr cos phi minus dr here, cos phi minus 1. Okay, taking all the terms to the RHS side, finding out the value of phi here, that is phi is equal to cos inverse of plus or minus k divided by 2 plus 1 here. Okay. Now substituting the value of k is equal to 0, 1, 2, 3, we will have the 60 degrees, 90 degree, 120 degree here. Now what is exactly the field pattern here? Just a definition here. A pattern showing a variation of the electric field intensity at a constant radius r as a function of theta and phi is called a field pattern here. Okay, simple definition has been given here. Now we have find out what you have find out is getting the phi value here. Okay, pattern maxima, phi value in pattern minima, and also the phi value when we have a major beam here. So if at all we consider all these things and draw this particular diagram here, so what we are having here is, see here it is minus 180 degree, minus 180 degree. It is nothing but here we are having the maximum radiation here, 0 degree, maximum radiation here, and okay. So pattern maxima is given at what angle here? He has mentioned here. It is 41.4. That is this here. Okay, 41.4. And also we have mentioned that at 60 degree we'll be having the first null here. Okay, the first null at 60 degree. 60 degree plus or minus will be having the first null. That's why it has been given as this here, 60 degree. Okay, right. Okay, this is how we are able to find the pattern maxima and pattern minima here. Okay, this is what you can say that which case here. This is it is end fire case here. Remember, end fire case means what is going to happen? Major beam will be along the axis of the array here, along the axis of the array here. Okay. Okay. So now let us move on to the next problem here. Again, this kind of problem here, not next problem here. Again, we have to complete this particular problem here. We know that beam width in first null is equal to 114.6 into root of 2 divided by L divided by lambda here. Half 4 is given already, divided by 2 of the beam width between first null here. TL is equal to n into d here. What is n here? We are having 4, number 4, and d is nothing but lambda by 2 here, distance between the two isotopy point source here. So you are having L is equal to 2 lambda here. We need to find the value of L divided by lambda here. Just taking to the LHS side here, L divided by lambda will be 2 here. Okay, substituting the value of 2 here, 2 by 2 is 1, root of 1 is 1. Okay, now the beam width within first null will remain same as it is. If at all we divide by 2, it is 57.3, half our beam width. Now compute the field pattern. The same 4.2, 4.6 equation is the problem is there. The same thing it is there, but with a different number of isotopic point sources here. Okay, so now they have given here. In this case, in the previous case, there was something called the phase difference was there here. Okay, between the adjacent sources here. Now in this case, there is no phase difference between the adjacent sources here. So hence delta is equal to 0 in this case here. Okay, 8 isotopic point sources are there here, which are spaced between, spaced from each other is lambda by 2 here. Okay, so n is equal to 8 here, d is equal to lambda by 2, and delta is equal to 0 here. So you know again the total phase difference, that is psi is equal to dr cos phi plus delta, you have to take care. Substituting the value of delta is equal to 0 and phi is equal to 0. Sorry, psi is equal to 0. So you will have dr cos phi is equal to 0, cos inverse of 0 is pi by 2 here. Okay. So what is the meaning here is maximum radiation will be generated along the, what you can say, the perpendicular to the axis here. This is perpendicular to maximum radiation will be generated perpendicular to the axis here. Okay. Now let us move on to the next one. If at all we wanted to find the pattern maxima, again sin n psi by 2, psi by 2 should be equated to 1 here. Okay, or a sine of something should be equal to 1, that is sine of 90 is equal to 1. So you can substitute the value of plus or minus pi by 2 into 2k plus 1 here. Okay, what is psi here? Psi is nothing but here your dr cos phi plus delta is there. Delta is already equal to 0, so n by 2 dr cos phi here. Okay, okay, now 2 to get cancels here in the denominator section here. So what we'll be having here is phi is equal to cos inverse of plus or minus 2k plus 1 divided by 8 here. Okay, this is how we can get the phi value here. Pattern maxima here, substituting the value of k, you will have this decrease here. Now pattern minima, again sine of something should be equal to 0. Sine of n psi by 2 should be equal to 0, means sine of something pi by 2. Okay, not pi by 2 here, pi, sine of pi is equal to 0. So that's why you written plus or minus of k into pi here. Okay, n psi by 2 is equal to plus or minus k pi here. Okay, n dr is nothing but here again psi is equal to what here, dr cos phi plus delta is already 0, so dr cos phi divided by 2 will be there, k into n, so is equal to plus or minus k pi here. Now if at all we wanted to find the phi is nothing but here cos phi is equal to plus or minus k by 4 here, or phi is equal to cos inverse of plus or minus k by 4 here. Now substitute the value of 0, 1, 2, 3 in the k, you will get the phi value here. There is nothing but a pattern minima here. Okay, so this is how we are going to represent the pattern minima here. See, pattern minima is been represented. This is what is the pattern, this is what is the pattern minima here, the smaller one. This is pattern minima, this is pattern minima, and this is also pattern minima. Sorry, maxima, maxima. This is pattern maxima. These are all the 6 lobes, no? Side lobes are nothing but here pattern maxima. This is main beam here, or major lobe here. And whatever the between the 2 minor lobes, there is 60 degrees, no? This is nothing but here your pattern minima here. Okay, okay. So let us move on to the next, or you can say the next parameter here, beamwidth within first null here. Beamwidth within first null in the case of end fire case. Remember this is sorry, not the end fire here. This is broadside case here. Remember, in the broadside case, the equation changes here. Okay, so what is the equation we are having here to find out the beamwidth within first null here? Beamwidth within first null is again 114.6 divided by L by lambda here. In the previous case, it was root of 2 divided by L by lambda here. Now in this case, just L divided by lambda here. Okay. So we need to find the value of L divided by lambda here. We know that L is equal to n into d is there. What is n? N is 8 here into lambda by 2. So 2 4 so 4 lambda will be there here. So L divided by lambda is 4 here. Okay, so that's why L divided by lambda is 4. So if at all we substitute the 4 value, we'll get at 28.65 here. Half power beamwidth is nothing but here, again divided by 4, we can make it here. Okay, so half power beamwidth is equal to 14.32 here. Okay. Now this is how we can solve the problems here. Okay. All the 7 problems are very important from the point of examinations here. Please go through carefully one by one problem here. Okay, if at all you have any difficulty in understanding in any part of the problem here, okay, so please message me, and okay, you can go through this document here. Okay, all the 7 problems are solved here, all the solutions and steps here. So make sure that you prepare very well. Okay, right.